This next video is dealing with patterns. With our patterns, we must be able to come up with filling in the tables. We need to be able to work with tables. We need to be able to come up with an equation. We're going to make equations, so it's y equals. We need to be able to talk about the relationship. Relationship would be between the x and y, who is dependent or independent. And we could be asked to graph. All right, so to look at all those different things, we're going to start with the table and come up with the pattern and fill in the blanks. So when I look at this, we have been looking at, okay, well, 4 and 5, they're right next to each other. So let's look over here. What is the change between these numbers? Well, these numbers go up by 4. We've talked about you don't want to just take the first pattern you get, you have to check it to make sure it's still true. So here I see that the 6 is missing, so I'm going to fill that one in. It goes up evenly, so I'm going to check this, and look, it again goes up 4. This one again, it's the next number, so I'm guessing my pattern of plus 4 should work, so that gives me a 28. Now, I can see there seems to be a 4 involved, but I need a pattern that relates these two, that puts these two in relationship. So now I'm going to look this way. Well, 4 plus 4? No, that wouldn't give me 16. But 4 times 4 would give me 16. Oops, so that's times 4. So I'm going to try the next one. Does 4 times 4 give me 20? Yes. 6 times 4? Does that give me 24? And yes. And 7 times 4, does that give me 28? And yes, it does. So I have found a pattern. What I am doing is I'm multiplying this set of numbers, which is all my x values. So I'm taking my x values and I'm multiplying times 4, and that is giving me my y. Now, the better way to write this is y equals, we always put our coefficient first, which is our number, and then our variable. We've also talked about what x is the input, or it's independent. So this is our x term. But whatever the x is, when we plug it in, so for instance, we plugged in that 4 times 4 gave us our y. So the y depends on what we plug in for the x. So y is dependent. It is the output. It's the answer that comes out. And it depends on what we put in. All right. Here is another one. So if we look at another XY table, if I have 2, 4, 6, 8, okay, and then I have 11, 13, and then 17, okay? Well, when I look at this, I can see these are going up by 2's. Okay, so these are going up by 2's. This is also going up by 2's, so that means, well, 3 must have been 10, and 5 was probably 14, and 6 would be 15, and then 7 would be 16. Okay, so yes, they're going up, but they're going up by 1. When I look this direction, did it go up by 1? Well, not really, right? So I'm going to try a different method this time. If I take 2 plus what is going to give me 11? Well, that is 9. All right, let's try the next one. 4 plus 9. Does that give me 13? And yes, it does. And we could even try 5 plus 9. And does that give us 14? Yes. So what we're doing is we're taking these numbers, so those are our x values, and it seems like we're adding 9, and that gives us our y value. So again, we always want to write our equations y equals x plus 9. Again, our y depends, and since it depends, it is dependent on our x value, which is independent. All right, now I want to show one more example. This is a word problem. And we definitely do these word problems, so we want to make sure that we're able to. All right, actually, here we go. So this problem says, a baker has 6 eggs left and goes to the store for more. Each carton of eggs at the store holds a dozen eggs, okay? So what we're given is, we're given a table, cartons and eggs, okay? And they want to know when we have 1 carton, 2 cartons, 3 cartons, and 4 cartons. Now, it says a baker has 6 eggs left and goes to the store for more. So I'm adding this in, but when we have 0 cartons.
Attention, softball conditioning is canceled for today. Softball conditioning is canceled for today.
When we have 0 cartons, how many eggs did it say we had left? Well, we had 6 eggs left before we even started. Now, when I have 1 carton, well, how many eggs are in a carton? A dozen. That means I have 6 plus I'm going to add 12 to that. So 6 plus 12 gives me 18. All right. And then I'm going to add another 12. And when I do that, I get 30 eggs. And then I get 42 eggs. And then I get 54 eggs. Okay. So, I'm sorry for all the distractions here. Eggs equals, well, we started with 6. We know we're buying cartons, right? But we're not taking 6 plus 1 carton. No, we're taking 6 plus 12 that are in each carton. So we're taking 12 times each carton that we buy plus the 6 that were left over. Now, when we look at this, in this case, which one is dependent and which one is independent? Well, the cartons are independent. What I like to talk about with the kids is this, the cartons of eggs are just sitting there in the store, okay? They're already put together. So our cartons are independent because they're already there. They're just sitting, waiting, happy to be in a carton. Now the eggs depends on how many cartons you buy. The eggs that you need must come from the cartons. They depend. So our eggs depend on how many cartons you buy. So that means our eggs are dependent. Okay? Now, we could graph this, and I'm just going to sketch it really quick. I'm not actually going to graph this nicely. My cartons is going to go down here, and my eggs are going to go up here. So when I have 0 cartons, I'm not starting at 0 on the eggs. Instead, I'm starting at 6 because I already have 6 eggs that have been left over. Now when I buy 1 carton, I now have 18 eggs because I have 12 that I bought in here plus the 6 that were already here. When I buy 2 cartons, I am now at 30 eggs because I have 24 plus the 6 that were left over, and it will continue on. We talked about this makes a line, and this is known as a linear equation. This linear equation does not go through 0, 0 because when our cartons are 0, we didn't have 0 this time. We actually already started having eggs. Right? Hopefully that helps. If you have any questions, please see me.